Hello guys, so today's video is more about Cortex Search. So we will understand what Cortex Search is, why we want to implement Cortex Search in our applications, and we will build one application where we will use natural simple English language to query uh, news data as well as trading activities, and we'll see how beautifully Cortex Search will provide us semantic meaning and results, interpretable results that is next to impossible with lexical rule based model builders, right? So I can query my database using natural language. So yeah, let's get started with Cortex Search. So as you can see, Cortex Search is a feature within Snowflake Cortex. It's a AI/ML suite provided by Snowflake. So it is designed to enable users to perform semantic search and NLP queries on their structured and unstructured data stored in Snowflake. So what is the service this Snowflake Cortex is all about? It is a AI ML service that is designed to enable the users of Snowflake to perform semantic search. That means you can do a semantic similarity search between your text documents and your natural language queries, and you can perform both the operations on top of structured data, that means your relational type of database, as well as your unstructured data. Okay, so there are traditional lexical support search, right? Lexical keyword based searches. So Cortex Search leverages vector embedding and AI model to understand the context and meaning behind the data, delivering more accurate and relevant results. So what is happening in Cortex Search? It is using vector embedding and AI model to understand the context and meaning behind the data, that means the query that you are delivering to Snowflake Cortex, and it provides you more accurate and relevant results compared to your keyword based searches. Okay, what are the key features of Cortex search in short? So first one is semantic search. So it understands the intent and context of the queries and not just keywords. So it is not a lexical search and it's a context based search, right? And the second one is it allows the user to search on concept, phrases, or ideas rather than exact matches. So it does not matches the keywords exactly, rather than it searches for the concept, or it searches for the similarity between the documents and the queries. Okay, so let's say you state something that has no keyword similarity with the result set, but your meaning of saying it interprets that the concept it interprets, and it returned the best matching documents. Okay, so that's what your semantic search is. Now the next one is your natural language queries. So it enables your user to ask question in plain English. So there is no SQL, no complex writing required to use Cortex Search. So your customer support team probably can use the service and ask question into the chatbot in plain English and get some meaningful result. That's pretty amazing, right? So let's say in example, let find listing with pool and near the beach, instead of using some complex SQL queries. So previously what we used to do, if the requirement is finding all the listing of pools uh, near the beaches, okay, then you have to write some complex queries, right? Select star ABC from in that kind of queries. But here you can directly ask this question and it will return you all the required relevant details basically from the database, okay, in a proper word retrieval manner. Third one is vector embedding. So what it does, it converts all the text data into your vector embedding, that means a numerical representation using pre-built AI models. So it makes easier for comparison between these documents and search for similarity context. Okay, so here one thing I need to mention, I think in Snowflake they have L1 similarity, L2 similarity, cosine similarity and dot similarity. These four type of similarities you can tweak. Okay, then the next one is unified data search. So you can work seamlessly across your structured data, your unstructured data, as well as PDF, document, JSON, as well as your relational databases, right? So you can work with both the data at the same time. So it is a pretty powerful feature of Snowflake Cortex. Then it has integration of with Snowflake, right? So you don't have to uh, go outside of Snowflake, write some complex code and code to manage the infrastructure and all. So it allows you to build everything, all the service inside Snowflake. And as it is built inside Snowflake, it is definitely can be scalable, and it will abide the performance metrics that Snowflake follows, right? So where you can use Cortex Search, so you can use Cortex Search in your customer support application, where quickly you can find relevant support tickets and FAQs based on customer queries. Then you can use it in e-commerce, so that questions like that, find red dresses under 50, and it will search into the database, and it will retrieve all the related information, and it will return you all the required details. So you don't have to do a custom filter kind of box there, right? Filter by color, filter by price tag. So the user will write in natural language, and Cortex Search will return all the relevant details it find in the database into the user context. Okay, there are many other things like content discovery, data exploration that you can go through along. So how to build a Cortex Search service? Basically, first, once your data is ready, you have to just create one Cortex Search, and the Cortex Search needs to be built on top of the text column that you want, on top of which you want to build this Cortex Search. And you have to include some of the attributes to include in the search, and also you can include filters, those filters for more fine grain filtering of your search criteria. And once the Cortex Search is ready, you can use natural language or any semantic queries to retrieve relevant results. Okay, likewise select star from blah blah, where your query equals to find listing with a pool near the beach, something like that. Okay, and then you can optimize your search based on the results you are getting and iterate over. Okay, so this is what overall simplified explanation of Cortex Search. Now we'll go through the document once, and we'll understand, and then we'll see these three tutorials one by one, built by Snowflake, and finally we will build our Cortex Search application on top of our trading data, where we have data regarding trades taken by different traders in different days, and we have some news article events in our database that captures some of the high impact news that may aggregate or that may influence some of the trades taken by the traders. And then we'll ask questions to Cortex Search service, and we will see if it is can give us satisfactory answers. Okay, so as we have mentioned, that Cortex Search enables a low latency, high quality fuzzy search over your Snowflake data. Cortex Search powers a broadly array of search experience for Snowflake users. It includes RAG applications that leverage your LLM models. Okay, so how Cortex Search build? It runs basically one hybrid search. There is one vector search and one keyword based search, okay, on your text data in minutes. And once that everything is done, then it performs a retrieval on top of that, okay, to give you the, and it re-ranks the results, semantic retrieval, basically semantic re-ranking it performs, and it gives you the highly relevant or correlated results based on the query that you asked. Okay, so when you want to use Cortex Search, so let's say you want to build one RAG based engine for your LLM chatbots, or you want to do a unified enterprise search in your company, then you can definitely go with Cortex Search. Now, okay, how Cortex Search works in a visual flow. So let's say you are asking some query into the system, then Cortex Search, as you have mentioned, it has two type of what search engines basically, right? So it runs a hybrid search engine that contains one vector database or vector embedding, and the second one is your lexical or keyword based search, right? These two, combining these two, you have your context documents already present in your database as well as stage, whatever. Okay, and this context along with the prompt that you are passing, it uses some Cortex LLM functions, let's say complete. Okay, and then based on this LLM response, it gives you the final contextualized response. Okay, so how to build a Cortex search? Definitely these are the boilerplate codes, like your database schema, your warehouse is present and all that, and let's say these are your text data on top of which you want to build the Cortex search. Okay, so first thing that you have to enable is you have to enable change tracking on top of the table, just like dynamic tables, so that Cortex search can track the changes happening in the table, and in background it can updates the DB. Okay, as we have mentioned, it requires a vector database, right, for its semantic search. Now once all of this is done, you have to create the service. So the context or the syntax for creating a service is like this. So I can zoom in little here, okay, so that you can have a good understanding. So this is, so it's create or replace Cortex search service. So this is your first boilerplate. Then you have to provide the service name. Then in this on, you have to provide the script name or the column name on top of which you want to build this natural language search capacity. So once you have provided that, then in attributes you have to mention all the required let's say filtering criterias that you want another additional columns to be filtered upon. So you, in attributes, you are mentioning, let's say in this case they are mentioning region, then you provide the warehouse, then you provide the target lag, and it's for definitely your freshness computation of the table, and then you provide the embedding model, what LLM you want for your Cortex search, and then you are selecting the columns from the source table. Okay, so this is what your Cortex search definition looks like. Okay, so whatever we have mentioned are mentioned here again. So let's go through again. Query the service, will search for the matches on this column. So this column we have mentioned that on top of this we want to build the Cortex search. Then the second target lag parameter, it dictates the Cortex search service will check for updates on the source table or base table, for like this support transcript, right? This is the base table, approximately once per day, as we have mentioned the target lag as one day. Okay, then your column region and agent ID will be indexed so that they can be returned along with the result of the queries of the transcribed text, as you have mentioned in the select query. In the select box, apart from your transcribed text, you have also mentioned region and agent ID. So these two will be indexed so that it can be returned along with the results, and the column region will be available as a filter column, as we have mentioned when querying the transcribed text column. So as we have mentioned in attribute region, so we can filter based on regions, okay, in the natural language query. And finally, this is the warehouse that we are going to use for materializing the results of the specified query initially and each time the base table is changed. Okay, so this is a dedicated warehouse that will be taken care for the computation and billing. Okay, so once this is done, you can also create Cortex search via AI ML Studio. So in AI, that will show in the hands-on. Okay, and in permission, you need permission on database, uses permission in database. Then you also required uses permission in schema. Then you required uses permission on the service. Okay, the role which is executing the Cortex search. Okay, and how you can preview the service, you can use this search preview function. So you use select parse JSON and you pass this search preview. Within the search preview, you pass all the details. Okay, that means the which column needs to be queried in the query, In the columns, you pass all the required columns, and in the filter, if you want to filter anything, let's say I want to filter with the equal sign of region equals to North America, something like that, and I want only one result, so limit 1. So in that way you can use this search preview to see that your data is getting populated in Cortex Search. So you can see the result like that. Or else what you can use another table function, that's Cortex Search Data Scan. This table function will also give you the details that the data is getting populated in the Cortex Search. Okay, you can also use Python API for querying your Cortex Search. So I'm not going through the code, but it's a possibility that you can use Python APIs to build your application, LLM applications or chatbots outside Snowflake using Streamlit, or inside Snowflake using Streamlit, that uses Cortex Search. Okay, and in case of privileges that you have already mentioned, uh, and if you need any more details, you can visit this section where you will get all the required understanding what are the privileges that is required for building or monitoring or altering the Cortex Search service. Then how to understand the quality of the Cortex Search. See, we have already mentioned, right? It does three things. First one is vector search to retrieve semantically similar documents. Then it does a lexical search, that means your keyword search to retrieve lexically similar documents. And third one, it is performing a semantic re-ranking for re-ranking the most relevant documents in the result set. And that's how it gives you the most relevant answer, that is most relevant to or most appropriate towards the query. So this is a hybrid retrieval approach that has a semantic re-ranking and high quality vector search as well as keyword search. Okay, and what are the models available? So you can see these are the models available. So another thing regarding token and limit, so these things I'm just ignoring right now for this tutorial. It will unnecessarily increase the video length. So you can go all of this, right, all of the stuff if you are interested, or your company is considering Cortex Search for any of your projects. So let's directly go into the code where we will be building some of the applications using Cortex Search. Okay, so this is the final applications that we are going to build. Okay, so first, in the first tutorial, what we are going to build, let's say we have some data, right? We have some data in this Airbnb listing. So let me first show that we have populated some data in this Airbnb listing. So here you can see you have ID, you have access, you have accommodation, you have address, you have amenities, you have availabilities. So these are some random owners update in their Airbnb application, and this is one Airbnb sample data set where you have details about some Airbnb facilities, what are the host, what are the house rules, interactions, last reviews, listing URLs. Okay, name, neighborhood overview, and notes, all of this. So a lot of text data is there, right? Summary, transit, weekly, priority. Okay, so there are many NLP complex code writing, right? So it will be requiring a lot of code rewriting, right? So if you want to write, let's say, in Brazil, I want to search for this amenities in this availability, I want to have a location like this, the owner has to be polite, blah blah stuff. And then if that information you have to convert it into SQL, and the engine will convert it into SQL and provide you answer, the SQL code will become very complex, right? So that's why you can use always semantic similarity search. As mentioned in Cortex Search, it uses semantic similarity to fetch you your relevant documents that matches your thoughts, that matches the context that you are speaking. Okay, So how you can build, so what on top of this Airbnb listing table, I want to build one Cortex search, right? That's how we want to proceed. So as we have mentioned already, right, in the documentation, how we can create a Cortex search, this is the syntax, right? So create or replace Cortex search service, right? So that's what we are doing. So we are create or replace a Cortex search service, and this is my database, this is my schema, this is my Cortex search service name, Airbnb SBC, and I want to implement that on listing text. So listing text is not defined here. So listing text will be a combination of multiple columns. So that's why we have defined the listing text here, as you can see. So what we are doing, we are combining summary, we are combining description, and we are combining space. Okay, and then we are calling it as listing text. Okay, so on top of this computed measure, basically we want to apply this Cortex search, and where our attributes will be room types and amenities. That means these two type of filters we are keeping. So once we are keeping this two type of filters, we need to include these two columns as well as in our select statement. So you can see room types, amenities are selected, as well as we are also including price and cancellation policy in our Cortex search. And we are using this Cortex search tutorial warehouse, 1 hour as target lag, Snowflake Arctic embed L version 2 .0 as our embedding model, and we are creating our Cortex search service here. So once the service is created, as we don't have inference available in the region where this account is, we are just altering the account, and we are just enabling cross region Cortex inference availability, and we are giving our zone as let's say AWS US. So if you don't know about this, don't worry, I'll create one short that will give you a good understanding about this cross region inference Cortex enablement. Okay, so don't worry about all of that, all of this, it's not a big deal. It's only when your region does not have the ability to compute over any LLMs, Snowflake allows you to do the inference cross region, and there are some costs and how the costs are getting calculated, all that stuff. So you don't have to worry much about it right away in the time of when you are preparing, right? So now once your Cortex search is ready, so you can verify all of these. Okay, how you can verify, let's just, we have already mentioned, right, how you can verify that the your Cortex search has data. We will use this query, right? We can use this parse JSON, where you can write this search preview, and you can see your Cortex search service is populated with data. Or else what you can use this Cortex search data scan, this table function, right? This portion is done, and press this and this, right? Okay, this is, you can see that. So you can see these are your generated embeddings. Okay, these are the columns that you have mentioned in the select clause. Okay, so you can see your Cortex search is populated with the right amount of data, and these are things that we will cover in the LLM section, so I'm not going to talk about all of this. So once your Cortex search is ready, now we can build one simple Streamlit application that will showcase this text. So if I just duplicate this, and if I go to Streamlit, let's say this is the first demo I'm hoping. So you can see this is one sample code that we have built. So this is, by the way, this code is available in the tutorial section. Okay, so where we have mentioned the filters as room type and amenities, right? So we can choose any option that's available. Room type, let's say we are choosing private. Amenities, let's say we are choosing gym. I required air condition. I required microwave. Okay, let's say I want only top 5 listing and query find all the listing in Brazil that matches the filter criteria. Okay, and you can see this is the summary and description that you are getting. Okay, based on price, cancellation policy, room type. So as we have mentioned, I want private room, so you can see all the rooms are private that I am getting. All the 5 records, all are 5 private rooms. Okay, and I have mentioned what I am requiring. I am requiring gym, air condition and microwave. So you can see I have gym, air condition and microwave in amenities for all of these results, and I want it in Brazil. So this all are the listings that is from Brazil, and you can see the price, the cancellation. So whatever the context, okay, what are the based on the context, you can see this is the search result. So if I, let's say, change the context, okay, find me the best place based on the criteria that has good visual surroundings. If I enter, and you can see based on the context, it is now giving me a different area. Okay, so here you can see the summary: best location in Sydney, within minute from Hyde Park and Sydney CBD, placed on famous Oxford Street but facing north onto a quiet park which provides tranquility when within the room. Nevertheless, it's surrounded by awesome restaurant and nightlife with buses running every 3 to 5 minutes directly to Bondi Beach. Okay, so what we have mentioned, that we have mentioned find me the best places based on the criteria that has good visual surroundings, right? So with keyword matching, it is impossible to filter like this. Someone has to navigate the listings and then has to go to the client. Now let's say if a customer support guy is having this chatbot, it is pretty easy for him to just or the user can itself query and see, okay, this is the listing that I am interested in. So the search becomes very effective and very less time consuming. So this is the first application that we have built, and this is the Streamlit code for it. So it's already available in Snowflake documentation. I'll link the documentation. Now the second tutorial is similar to this. It's only it has one additional UDF code. So this UDF code, what it implies, it's just chunking a large paragraph data into chunk. As if you see in the Cortex search, Cortex only works good with a small chunk of data. So if your data size is smaller, then it will be this token limit and text splitting. In this model you will understand. If you have a very short span of data or sentence, then your Cortex search will be much more effective, and it will give you a much more better result compared to a long string or long sentence. Okay, so this code is from LangChain. What we are doing, we are importing text splitter for doing recursively character text split. So we are just defining one class as text chunker, and then finally in the method of process we are yielding the titles, authors, and these are some metadata that we are yielding along with the chunk of data, a chunk of this repeated text that we are getting from this text splitter object basically. Okay, So once that is done, we are recreating another table from our main table. Okay, and once we have created done with the recreation of this table with the chunk of data, we are applying the Cortex search on top of that chunk. And once we have done applying the Cortex search, it is ready for search. So if we go to the Streamlit application again here, so this is I think demo 2, alright, tutorial 2 to demo 2. Yeah, let's wait a few seconds. In the left hand panel, you can see whether to use the chat history, whether to debug, and which service you want to use. In the left hand side, let's say I'm using the Cortex Search on top of this books data, that is FOMC meetings. Is it correct? Or books dataset service that I have to use. Okay, and let's say I'm asking, okay, give me all the books details that are similar to Harry Potter. Okay, so you can see based on the provided context, there are two books that Cortex probably find it's contextually similar to interests of Harry Potter, right? So this book is directly related to Harry Potter as it provides hints about the fifth Harry Potter book and suggests secrets, subplots for future volumes. Okay, and this is another element that it suggests. Okay, so this is the second application. So in third application, what they did the same Cortex search. So they apply the same Cortex search, but they have increased a bit, complexity. They are now applying the Cortex search on top of PDF data. So what they are doing, they are using PyPDF to scan the PDFs, then convert that PDFs into text. Then again, they are using the same recursive character text splitter to split the text into uh, your small chunks of sequence. And once that is ready, on top of that table they are applying the Cortex search. And once the Cortex search is ready, you can ask questions. So these three tutorials they have built, so you can see and follow along for better understanding, and then you can build your own. So likewise in this case, what we have done, we have taken one trading example, right? So let's say this one, right, this trading demo. If I go to this, right, so here we have created one table that is named as trading data, that have all the trading activity done by different traders in different days. So we are collecting in which stock they are doing the trade, the unique IDs, the stock symbols, the date, the price, the volumes, the trade types, whether it's buy or sell, whether what is the trader's ID, what in which exchange they are performing, what is the order type, whether it's market or limit, what are the status executed, pending, and cancelled. Okay, and then we are inserting random data there. Okay, and we are also creating one news articles table where we have article ID, stock symbol. So this defines the stock. The news is about which stock, then the published date of the news, then what is the headline, what is the content, what is the source, and the sentiment. Okay, so these are the two tables. So we will build, what we will gonna do, we'll build Cortex search on top of these two tables. Okay, so on top of these two tables, and then we'll build one chatbot that will give us the context of these two tables combined, and we can ask some pretty complex questions, and you will see that chatbot will efficiently handle all those questions and will return us results. Okay, So first, on top of trading search service, we are trying to apply the Cortex search. So in trading search service, what on top of which columns we want to apply? We want to apply on the trade text. So how we are forming the trade text? We are combining the trade details, the stock name, the date name, the price name, the volume name, the trader name, the exchange name, and we have termed it as trade text. And on top of trade text, with filter of stock symbol, trade type, trader id, and exchange, we are creating a Cortex search. Okay, and in case of the news, we are combining the article, headline, content, source, and sentiment. And on top of this news text, we are creating this Cortex search with filter like stock symbol, published date, source, and sentiment. Okay, so once this both the services got created, okay, let's go to the application layer. So in application layer, I think this one is the okay, yeah, this is the application. Let's wait for it to load. So here you can see we have loaded the data. So it is requiring two Cortex search application. The first one is for trading data. So for trading data, I know it's trading search service, and for Cortex search for news, I know it's news search service. Okay, and I'm using this chat history, and I have created some questions. Like the first question is, Microsoft launches new cloud service. Is there any impact on the trades done? Okay, so if I ask the question to the chatbot, basically, let's see how it replies. So you can see, based on the provided context, there is no direct impact of Microsoft launching a new cloud service on trades done. The trading context only shows the details of Microsoft trade, such as stock price, volume, traders, exchange, but does not provide any information on how the news event, like a launch of new cloud service, impacts the trades. Similarly, the news context only provides information on the launch of new services by Microsoft, but does not mention any impact on trade. So the response is very meaningful and consumable for the front end guy or the user, right? So let's now jump into the second query that we have, that is, Microsoft launches a new cloud service. Is there any trade done by any trader after that news on Microsoft? So this question will give, I think, more meaningful result, I guess. So let's just wait. Okay, so as you can see, based on provided trading context, there were trades done by traders after the news of Microsoft launching a new cloud service. The trades were done on the following dates. You can see done by 9th, 11th, and 13th by trader 30, 40, and 50. Okay, however, the context does not provide any information on whether these trades were influenced by the news of Microsoft launching a new cloud service. Now imagine only this question. Okay, you want to retrieve the data of this question, like these three information from your database. How many hackled situation you have to face? You have to write any SQL code, right? Any SQL complex SQL code. It's first of all, it's not completely possible with lexical search, right? You have to use some let's say machine learning, this semantic search and all this. But how many infrastructure details, Python code or Kubernetes clusters you have to manage, right? And here nothing you have to do. You're just connecting your database. You're just building one service inside Snowflake, and you are asking questions, and it is providing you the result, right? So it's like a co-pilot for your own company's data. Now let's say the third question that I have here. Okay, when the highest volume of shares are traded for Netflix, and is there any news around that? And let me tell you, we don't have any data regarding Netflix in the database. So as you can see, the provided context and chat history does not contain information about Netflix trades or news. Therefore, I don't know the answer to that question. So it's pretty accurate response given by Cortex, right? That there is no response or record for any Netflix account. Then in the fourth question, let's say what is the question? When the highest volume of shares are traded for Tesla, is there any news around that? Okay, so let's see if I ask this question. Okay, then it is again saying that the provided context and chat history does not contain information about Tesla trades or news. Therefore, I don't know the answer to the question. Okay, let's modify this question. Okay, when the highest volume of shares are traded for Tesla. Okay, just ask this question first. Okay, so you can see the highest volume of Tesla shares was traded on this October 17, 2023 with a volume of 1450. Now we can use this chat history feature and we can ask more question based on this trade. Okay, which trader, let's say asking another question, performs this trade. So as you can see, it can perfectly answer, right, based on the previous context. The trader who performed the trade with the highest volume of Tesla shares on October 17 or 18, 2023 was trader 078. Okay, now whether it's a buy or sell. So it is failing to answer this question whether it's a buy or sell. Okay, now let's just which type of trade it was. Again, it is failing to answer. Now let's ask some different questions. Okay, is there any trade performed on Google stock? Okay, let's ask this question. There should be some data regarding Google, I guess. If I see, yes, there are some Google data that are available, right? So let's see. Yes, there are multiple trades performed on Google stock. The details are as follows, as you can see, on October 15, 2013, October 16, October 8, and October 5. So these are the trades that were performed on Google. These are the traders who performed the trade with this exchange. These are the volumes. Okay, and in this price. Okay, now let me just find one question uh, from the news database in Google. Okay, news articles. Okay, Google launches new AI powered search. Okay, let's ask any trade happened during this particular news. So you can see, yes, a trade did occur during this time when the news article Google launches a new AI powered search was published on October 8, 2023, and you can see this is the details, right? So this is how you can build a Cortex Search chatbot that can communicate with your database in Snowflake, that can communicate multiple databases, multiple tables at the same time, and it can understand the contextual meaning of the data, and then it can retrieve and answer to your questions, basically your user based questions, very efficiently without you have to worry about the infrastructure, the latest models and all, right? Anytime there is a latest model or you want to experiment with different LLM models, you can just change the definition of the cortex. You have to be cautious about the model budgets or the costing, That's it. Apart from that, every infrastructure will be maintained by Snowflake. So that's it, guys, for this tutorial. In this tutorial, we have learned about Cortex Search, and we have used Cortex Search for building one simple chatbot, but yet powerful, that will integrate the data of trading activities with trading news and provide the user or the customer support more meaningful, or the analyst team more meaningful results based on the details available in the dataset, and that is less hectic and more human friendly. Okay, so we'll meet you in the next tutorial session with another tutorial in AI, data engineering, data science. Till then, goodbye.